We're getting ready to start the next lesson, and we're still going to be factoring. So the thing about today is it specifically says in the core content that when you factor and the beginning expression is not a 1, okay, then those are considered the harder ones, and specifically spells out in Math 1, you're supposed to get up to factoring trinomials. But when it says the a value is not 1, that means there could be a number a in front of x squared. The number b could represent the number in front of x, and the number c could represent the number at the end. So up until this point, we've always had a 1, an imaginary, implicitly invisible 1 that's always been there. So up until this point, when we have factored, it's almost like a given. I can just put x and x. And I only really had to worry about the last expression and the middle expression. But as of today, we now have a new factor to consider, and it's going to actually change how we're going to approach it. These are considered the harder ones. These are going to take more trial and error, and the reason I say that they're going to take more trial and error is because you're probably not going to be able to just look at it and pick out what they are immediately. Okay? It's just going to take a little bit more effort. The whiteboards that you have right now are great because not only can you just, have a place to work, but you can erase it so easy. Okay? Does everybody have a copy of the notes from up here? Okay. Let's jump in. Factoring trinomials with a coefficient of x squared, not 1, does require some trial and error. These are the same steps. You'll notice the first 3 things have never changed since I first talked about factoring trinomials. We're going to factor the first term. So we're going to look at the front. We're going to factor the last term. So we're going to look at the back. Then we're going to check the middle terms by checking what? Outers and inners. Okay? That is going to be very important, especially today. Now, everything that we've been doing the past few days, when the last term is positive, the signs are the same, and you'll mentally add to get the middle. The middle term wins both signs. When your last term is negative, that's a clue that the signs are different, and you're going to mentally subtract to get the middle, and the bigger number wins the sign. Those kinds of things that we've been practicing won't change. What is going to change? All right, let's jump in and do the first one. Okay, this is still a trinomial. I'm still going to attempt to factor it into 2 sets of parentheses. But now instead of going x and x, I have to ask myself, what's going to multiply to give me 2x squared? What's going to multiply to give me 2x squared? Well, 1x times what? 2x. And the lucky thing for us on the first one is there's only one way to factor 2x squared. It really doesn't matter which parenthesis you put it into. I'm just simply going to put 2x in the first and 1x in the second. And of course, if you only put x, that's fine too. Then we're going to factor the last term. How do I get negative 4? Or how do I get 4? I'm going to consider 1 times 4 is 4 and 2 times 2 is 4. Now, I know from my clues, I know that I'm going to mentally do what? Subtract. And when I mentally subtract, I'm going to try to get up with what? Negative 7. Well, 4 doesn't give 7. But I have to remember that when I do inners and outers, I'm going to end up multiplying something by a 2. Do you understand what I'm saying? What do you wish to check first? Do you want to check 2 and 2, or do you want to check 1 and 4? Because we're just going to put these in here and then check to see if we're on the right track. Someone said they want to check 1 and 4. Okay? All right. I'm just going to put 1 and 4. Now, you have your whiteboards. Now, you can work with whiteboards. That's fine. But also work with me in here. We know one sign has to be positive and one sign has to be negative. Because when you mentally subtract, the signs are different. I'm going to do the smile. What's 4 times x? 4x. What's 2x times 1? 2x. Oh. If I mentally subtract, that does not give me 7. So, I tried it out. That does not work. So, I'm going to erase this idea. I tried it. Just didn't work. What do I want to do next? Do I want to try 2 and 2? Or do I want to try switching positions with 4 and 1? You want to switch positions? Or do you want to try 2 and 2? Let's switch positions. I'm going to put the 4 on the outer one and the 1 on the first one. Now I'm going to try. You ready? What's 1 times 1x? 1x. What's 2x times 4? 8x. Ah. If you mentally subtract 8x and 1x, you end up with what? 7x. Does everybody see that? So I think I've got the numbers in the right spot, but now I have to check my signs. Everybody ready to check signs? The bigger number matches the sign of the middle term. The bigger number is 8. So I end up needing 8 to be negative, which means 1's going to be what? Positive. Everybody agree with that? You're going to have to trace back. I did not get 8 just from this number. I got 8 from the 2 times the 4, didn't I? 2 is already positive, so 4 needs to be what? Negative. Tracing back from the 1, that's 1x times positive 1. So now I should have my answer correct. And I don't have to keep this. That's a mental check step. But in our case, especially since we have whiteboards for today, it's actually going to be a physical check step. I'm going to ask you to check your answers. Do you understand what I'm saying? You may not be able to see the answer immediately. If you can, great. But if not, you may have to try some numbers, switch places. If they don't work after you switch places, take them away and try some else. Okay, let's go to the next one. How do I factor 2x squared? Factor the first term. 2x times 1x. How do I factor 6? 1 times 6 or 2 times 3. It's not too many combinations. So I'm going to definitely say, okay, 2x and 1x, and it doesn't matter to me which position you put them in. I'm going to take a look at my signs. So the last one is positive, so I'm going to mentally what? Add to get 13. Do I want to try 2 and 3, or do I want to try 1 and 6? Okay, I heard 2 and 3. Where do you want to put the 2? Where do you, 1 and 6 works? What if I didn't know that and I tried 2 and 3? Well, so it would be 2x. That would be what? 6x. Ooh, gives me 8x. Do you understand? Now, what if I switched? Would that have helped? What if I'd switched places? If I'd put a 3 here and a 2 here, I would have gotten 3x and 4x. No, that wouldn't help. So even when I switched, 3 and 2 just will not work. So you guys, who saw it right away? Anybody see it right away? What's the combination? Where do I put the 6? Where do I put the 1?
1 is on the end of the first one.
1 is on the inside, first one on. 6 needs to go on the out one. Does everybody see that? It's not that these are harder. Well, they're called harder because sometimes you might not get them immediately. Okay? So I was still checking 1x. I'm going to check what? 12x. Sure enough, it's going to add up to be 13x, but I need them to both be what? Positive. So I need a positive 1, and then I need a positive 6 so that I get positive 12. Everybody good now? Okay. These are not supposed to be so hard. You're still factoring the exact same way. The only difference is now you have an extra factor in the front to consider. Okay. Let's go to number 3. This one should be easy. How many ways are there to factor 5x squared? Only one, right? 5x times 1x. How many ways is there to factor 2? 1 times 2. What is my strategy? What am I going to mentally have to do to get my middle number? I'm going to mentally what? Subtract to get 3. Kind of set yourself up to where you know. So what do I start with? 5x and 1x. Where do you want to put the 2? Where do you want to put the 1? Does the 2 go here or here? Did I put them in the right place? 1x and 10x. Ooh. Even if I subtract, I don't get anything close to 3. So chances are I put the 2 and the 1 in the wrong place. So now I have to do what? 2 goes here and 1 goes there. Do you see how that check step now is very, very important to you? Where you really probably didn't need it as much in the past? So I have 2x. This is going to give me what? Which sign goes with which parenthesis? My middle term is what? Positive 3. My bigger factors has to be, the bigger number wins the sign. So the bigger number needs to be positive. Now notice that this is positive and this is what? So I need the plus with the 1 because those two come together to make 5, and that makes this one negative. So I would have had a negative 2x and a positive 5x to give me positive 3x. That was probably the easiest one on the whole page. You know why? There's only one way to get 5x squared, and there's only one way to get 2. So being as that's the case, you just had to put them in the right places. So ideas and thoughts as of right now. Everything okay? Let's go to the next one. Okay, some of you I know are probably ahead of me. What are some ways I can factor 8x squared?
42.
Okay, I heard 4x and 2x. What else? 1x times 8x. What are some ways that I can factor 6? 1 times 6 and... So I actually have 2 ways to get the first and 2 ways to get the second. I don't remember the final answer. What do you want to try first? See, I could say 4 times 2, 1 times 8. These are x's. I could say 1 times 6 and 2 times 3. Now, let's mentally set ourselves up. What are we going to do to get our final answer? We're going to mentally do what? Subtract to get 13. Does everybody get that? Now, you could kind of eyeball it. Okay, what do you want to try? 4x and 2x? We mentioned those first. What do you want to try? 1 and 6 or 2 and 3? 2 and 3. Did I get it? Okay, I'm going to check inners and outers. I get 4x and 12x. Ooh, even if you subtract, that only gives me 8. Okay? Now, only change one set of factors at a time. Well, before we say 3 and 2 don't work, what do we want to try? Switch places. So I'll put a 3 here and a 2 here. What does that give me? 6x and 4 and 8x. Even if you subtract, you only get 2. That still doesn't work. Well, 3 and 2 do not work with 4 and 2. Do you want to try 1 and 6? Okay, see what we're doing. So now I'm going to try 1 and 6. So, okay, 2x and 24x. Ooh, yuck. What if I switch places? Does that work? 6 and 1, 12x and 4x. If you subtract, you only get 8. Guess what? I tried 4 and 2 with every single combination, and 4 and 2, what? They do not work. They just don't work. So, I got to clear my board. That's where whiteboards are handy. Otherwise, you'll be using a lot of pencil eraser about right now. So, I'm finally know it's got to be 8x and 1x. Okay, you want to try 8x and 1x with 6 and 1 or 2 and 3? Now, you know if you multiply 8 times 6, that's going to be big, isn't it? I'd probably try 2 and 3 first. Where do you want to put the 2 and where do you want to put the 3? 2 in the front, 3 in the back. Okay, 2 times x is 2x, and 8 times 3 is what? Ooh, 24. That's too big. 24 minus 2 is 22. It's still way too big. Did you get it? Anybody got it yet? Finally got it? Somebody? I think it finally works if I put the 3 in the front and the 2 in the back parenthesis.
Oh, I have my 1 over here and 8 over here.
Oh, it didn't. Oh, that should be fine. Your parentheses should end up with the same things in them.
Okay.
I mean, what I mean by your parentheses may be, but you should end up with the same things. So you get 3x and 16x. Okay, now this time my bigger number wins the sign, so my bigger number is 16, so it should be negative 16, so 3x should be what? Positive. So trace back. I need this one to be positive 3. Going back over here, it's 2 needs to be negative, so negative 2 and 8 would be 16. Everybody see? How many times did that take us? Took us like 3 or 4 trials, didn't it? If you get lucky, you might get it the first or second time, but if you don't, just keep trying. All right, is that our last example before I've got some on the side? Okay. So our final answer, and like I said, if you have your x minus 2 parenthesis in the front and you have your 8x minus 3 in the back, plus 3 in the back, that's okay. All right. I did change. Remember, if you made the change, we do change the last one. And so it does check your answers before we move on to the next part. Okay, checking your answers. Matter It really doesn't matter whether you have like one parenthesis in the back or the other parenthesis in the front, as long as you have like, as in this one, you have a 3x minus 4 parenthesis, and then another one you have 2x plus 5. Now what's inside the parentheses must be exactly that, but the order that you write them doesn't matter at all. All right. Okay, we're going to flip to the back side. There's good news and there's bad news.
Oh, great.
The good news is there is an alternate way to do these that a lot of students prefer. Okay, it can be easier, but I will tell you it requires memorizing a pattern, memorizing a procedure. I'm just going to show it to you, and you can always do trial and error, and that's pretty much what we've done. It's trial and error. But the inners and outers, like I said, is ultra important. You cannot really get it factored unless you check that middle term to make sure you got it right. Okay, on the other side, these are like part 2. It's called slide, divide, bottoms up, and that's the strategy. Some people think it's easier because you don't always have so many combinations to check. So it takes a little bit out of having to check and do so much trial and error. But there are steps you have to follow, and if you miss a step, you're going to miss your factors. All right. If you'd like, go ahead right now and fill in your chart. Step 1, we're going to look for GCF first. Step 2, we're going to slide, divide, and then step 6, bottoms up. Okay. So I will let you pause the video while you copy the steps, and then we're actually going to put the steps into action. All right, now that we've all had a chance to copy the different steps, let's put the steps into practice. There is one thing about this. It is very steppy, and you're going to have to memorize the steps if you choose to use this. The advantage is there's not really much trial and error, but it is memorization of steps that have to be followed in order to get the final answer. Okay, step number 1, we're going to slide. So I'm going to take the A value in the front, which is the 7, the B value is 29, and the C value is 4. I'm going to slide the 7 and the 4 together. What is 7 times 4? 28. Okay. We're going to put that on top of an X puzzle. So we're basically going to organize that number. 29 goes on the bottom of an X puzzle. So basically I'm going to add the 2 to get 29, and I'm going to multiply 2 numbers to give me 28. Now, what it did is it took away this extra factor of 7 in the front. So now I'm asking you, what numbers multiply to give 28 that add to be 29? 1 times 28, right? 1 times 28. And so now I put them in my parentheses. Let's put them in parentheses. You will actually have to do parentheses twice. So we're going to put them in parentheses with an X and an X already built in. So it's almost like we went backwards to the ones that didn't have the numbers in the front. And so now it's going to be plus 1 and plus 28. We solved the new X puzzle that we got from sliding the A and the C number together. Is everybody okay with that? So 28 plus 1 adds to be 29. We've solved the new X puzzle. But that's not the overall problem I want to solve. I want to solve this one. So the next step says we've done the slide part. We've solved the X puzzle. Now we're going to divide the numbers by A. Which number is A in this problem? 7. So I'm going to come in here and I'm going to divide by A. So I'm going to divide the 1 by 7. Not the X, just the numbers. Divide this 28 by 7. When I finish this step, I'll have my final answer. Okay? So, new sets of parentheses is your final answer. Does 1 divide evenly by 7? No. Since it does not, this is where bottoms come up. The bottom number 7 comes up in front of the X and becomes 7X plus 1. Do you see how the bottoms up works? Okay. Does the 28 divide by 7? Yes. So that becomes X plus 4. 28 does divide by 7 4 times. This is your final answer to your this is slide divide bottoms up. I could have gotten the same thing if I had done 7 times 1 and 1 times 4. This is a different method. Now, it's steppy. Some students love it and use it. Some don't worry with it. I have a preference. You will have a preference. Does everybody understand what I did? Now, right now, you're probably thinking, boy, that's a lot of stuff to remember. I don't know if I like that or not. I can do the other thing. Let's just do a few more. So I want you to have, it's like this. There's always two ways to accomplish something. It's best to have a full understanding of both ways. Then you have a choice. You can pick whichever one you feel is best for you. Everybody understand that? All right, let's do another example. Let's do example 2 on the next page. Okay, let me clear that. Okay, first things first. What do we do first? Slide. What am I sliding together? The 2 and the -9. Right? 2 and -9 is -18 when I multiply the A times the C. That's on top of an X puzzle. So I'm going to multiply two numbers to get -18. So I'm multiplying to get -18. Now I'm going to actually combine the two numbers and get what? -3. Mentally, you are going to subtract, but technically you're adding. What multiplies to give -18, that's going to mentally add to be -3. -6 and 3. And that would be a +3. Does everybody agree with that? Yeah. All right, if I hide the bottom, -6 times +3 makes -18 when I multiply. If I had the top, -6 add +3, it would be -3. So that's my first set of parentheses. X minus 6, X plus 3. Not finished yet. All I've done is the first part of the slide. Now I have to divide. What number do I divide by? I'm going to divide by A, and the A number is 2. So I take here and divide by 2. Over here, divide by 2. My final parenthesis will be my last and answer parenthesis. Does 6 divide by 2? Yes. So that's going to be X minus 3. Does 3 divide by 2 evenly? No. This time bottoms move up in front of X. Bottoms up. 2X plus 3. Now, how do you know for sure that that is correct? Guess what you can always do to check the middle term? Inners and outers. That's -6 with X. That's +3 with X. And when I combine, I do get -3X, which checks the middle term. Okay, now we've done 2. You had a chance to check, right? We're only going to do 2 more, and then I'm going to let you do class practice to finish your day. Okay, next one. Always look to factor out what? GCF first. What GCF would factor out of 4, 22, and 10? 2. So it's easiest to factor out of 2, and your numbers will not be nearly as large. So what do I factor out of 2? Divide out of 2, divide out of 2, divide out of 2. What do I get? 2x squared minus 11x plus 5. Now, I don't think it's going to take too much to factor this because there's only one way to factor what? 2x squared, and there's really only one way to factor what? 5. So we don't really have that much choice. I think we could probably go to it right like this. Don't forget your baby at the mall. Bring the 2 down. I'm going to factor this the old way. 2x and what? 1x. Anybody want to guess where we put the 5 and the 1? Okay, we're going to mentally add. We're going to mentally add to get what? -11. So I need to put the 5 out here and 1 here, and that would give me 1x, and it gave me what? 10x. That has to add to be -11. So I need what? A -1 and a -10. So if I trace my way backwards, -5 and -1. Now Miss Jessup backtracked and did that one by guess and check. If I only had a few combinations, I would probably never do slide divide bottoms up. Let me tell you when slide divide bottoms up is the best, or when I think it's an advantage to use it. Let me jump back for just a second. Do you see problem number, 4, for example? How many ways were there to do, how many ways were there to factor 6x? 2. So there was 1x times 6x. There was 2x times what? 3x. How many ways are there to factor 20? 1 times 20, 2 times 10, 4 times 5. 2 ways here, 3 ways there. That's a lot of combinations when you switch places, right? There's a lot to check. I'd probably just jump in and do slide, divide, bottoms up. But if I had one like this, or like the one we just did, where I only had really one way here and one way here, and I'd have to switch most one time, I'd probably just do the guess and check. Everybody okay? All right, but I still want to do one more. Let's do the last example. Is there a greatest common factor in 6, 13, and 6? No. Okay, I'm going to do slide, divide, bottoms up. First thing I want to do is take the A and the C and slide them together. What's 6 times 6? 36. So I multiplied two numbers and got 36. Top of an X puzzle. 13 goes on the bottom, and I'm going to mentally add to get 13. So I want to solve this puzzle first. What multiplies to give 36 is going to add to be 13. 1 times 36 is 36. 2 times 18 is 36. 3 times 12 is 36. 4 times 9 is 36. And 6 times 6 is 36. All right, so 4 and 9. So we solved the simple X puzzle, and it is a positive 4 and a what? Positive 9. So we will have one set of parentheses to begin with, but that first set of parentheses is not our final answer. What's the next step? We've done the slide, and we've solved our first parentheses. Now what? Slide, and now we got to divide by 6. My A value in the front is 6. 4 divided by 6, 9 divided by 6. Neither one work. But I do notice something. Do you notice that 4/6 can be reduced? I need you to reduce that if you plan to use slide, divide, bottoms up. Okay? So if we reduce that, what does 4/6 reduce to? 2 and a 3. Do not use the 4 and the 6. Does everybody get that? So this time, that does not divide evenly. So 3 is going to move what? Bottoms up. 3x plus 2. 9/6 also can be reduced. 3 goes into 9 how many times? 3. 3 goes into 6 how many times? 2. Again, 3 halves does not work, so what do? 2 is going to go bottoms up. 2x plus 3. If you want to mentally confirm that that's right, inners is 4x, the outers is 9x, and sure enough, they do add to be positive 13x, which checks my middle term. So as of now, you can either do, and you have your whiteboard still, you can either do guess and check, and just change your factors, switch them out, just try new combinations, or you can do slide, divide, bottoms up, but I want you to caution you, if you do not remember all of the steps, you might not end up with the correct answer. So at this point, I have some class practice for you, and we're going to just finish up our day with that.